Welcome to the Explainer. Today, we're going to tackle something that's absolutely critical for any researcher working with peptides, and that's the math. We're going to demystify all the numbers and give you a super clear step-by-step guide to make sure you're safe and accurate every single time. So let's just start with the most important point right off the bat. The biggest danger when you're working with peptides, well, it's not usually the molecule itself. It's the simple, totally preventable calculation mistakes. A misplaced decimal, a mixed-up unit. That's where the real risk is. To get the math right, we've got to speak the same language. And that language really comes down to two key measurements, mass and volume. Get these two down, and you're halfway there. Okay, first up, mass. This is just the actual amount of that freeze-dried or lyophilized peptide powder that's sitting in your vial, and we measure it in one of two ways, either milligrams, which you'll see as mg, or micrograms, written as mcg. Now, if there is one thing you burn into your brain from this whole explainer, make it this. 1 milligram equals 1,000 micrograms. Not 100, not 10, 1,000. This is everything. Yeah, see, the scale difference here is just massive. A milligram is the big one, a microgram is the tiny one. And mixing these two up, it is without a doubt the most common and dangerous mistake you can make. It can throw your dose off by a factor of 1,000. All right, next up is volume. This is simply the amount of liquid you're going to add to that powder to bring it into solution. We're usually talking about bacteriostatic water here, and we measure it in milliliters or ml, and in those little units you see on a syringe. So when you look at a standard U100 insulin syringe, which is pretty much the go-to for this, 1 full milliliter of liquid is exactly 100 of those units on the side of the barrel. That relationship is key. So you can think of it like this. Each one of those tiny little tick marks, one single unit, is just 1/100th of a milliliter. It's a tiny amount. So 10 units is 1/10 of a mil, and 100 units fills it up to 1 full milliliter. Okay, now that we're all on the same page with the units, let's get into the fun part, the actual calculation. I'm going to walk you through a really simple 3-step process that'll get you an accurate dose every single time. We're just going to go right down the list. Step 1, figure out how strong your solution is. Step 2, find out how much of that liquid you actually need. And step 3, translate that amount into syringe units. Simple as that. To make this super practical, let's use a real-world example. Let's say you've got a vial with 5 milligrams of peptide. You're going to add 2 milliliters of water, and you want to pull a dose of 250 micrograms for your research. So step 1, find the concentration. All this means is how much peptide is in each milliliter of water. And to find that, you just divide the total amount of peptide by the total volume of water you added. In our example, that's our 5 milligrams of peptide divided by the 2 milliliters of water. And that gives us a concentration of 2.5 milligrams per milliliter. Easy, right? All right. On to step 2. Now we need to figure out exactly how much of that liquid we need to draw into the syringe to get our target dose. The formula here is your desired dose divided by the concentration we just figured out. But whoa, hang on a second. Here's a critical check. Our units have to match before we can do the math. Our concentration is in milligrams, right? But our dose is in micrograms. So first we have to convert that 250 microgram dose to milligrams. We just divide by 1,000, which gives us 0.25 milligrams. Now, we can do it. Our dose of 0.25 milligrams divided by our concentration of 2.5 milligrams per milliliter, that equals 0.1 milliliters. That's the volume of liquid we need. And for the grand finale, step 3. We just have to translate that 0.1 milliliters into the language of our syringe, into those units. And to do that, you just multiply the volume in milliliters by 100. So our 0.1 milliliter times 100 gives us 10. And there's our answer. You would draw the solution up to the 10-unit mark on your syringe to get that perfect 250 microgram dose. See? Not so bad. Okay, now that you know the right way to do it, let's talk about the biggest mental trap people fall into. Honestly, understanding this is just as important as memorizing the formula. So here's the question that trips up so many people when they're starting out. If you've got a 5 milligram vial of peptide, does adding more water, say 4 ml instead of 2 ml, somehow give you more peptide to work with? And the answer is a big, fat no. The amount of powder in that vial is fixed. It's 5 milligrams, period. All you're doing by adding more water is diluting it. The solution becomes less concentrated, which just means you'll have to draw a larger volume to get the exact same dose. So to wrap all this up and make sure you're safe every time, let's just run through a really quick 5-point safety checklist. Think of this as your pre-flight check. 1. Always, and I mean always, double-check that milligram to microgram conversion. 2. Use an online peptide calculator to check your work. It's a fantastic safety net. 3. Make sure your final dose is actually big enough to measure accurately. Anything under 5 units can be really tricky. 4. And if your dose is too small to read, well, next time, just add more water to make it more diluted. And 5, the easiest one. Label your vial with the date and the concentration you calculated. And really, that's the whole takeaway here. This isn't just about plugging numbers into a calculator. It's about building a system, a habit, a practice of being precise. Double-checking, verifying, labeling, that's what keeps your research safe and reproducible. So I'll leave you with this question to think about. What's your system for making sure you get it right every time?